Let's just get a little bit of practice now using the change of base formula. So first of all, let's look at log base 4 of 8. So we know that if we were to set this equal to x, we could solve this by taking 4 to the x is equal to 8, and then using kind of a matching base type thing. We know that 4 is 2 squared to the x, 8 is 2 to the third. So we get 2 to the 2x is equal to 2 to the third. If I took log base 2 of each side, what I would end up with is just 2x is equal to 3. Since I'd end up with 2x times log base 2 of 2, which is 1, and 3 times log base 2 of 2 from my algebraic properties of logarithms. So I would end up getting that x is equal to 3/2. So now I'm going to claim there's a different way we could do this, using the change of base formula. So remember that the change of base formula tells me that I can take log any base I want of 8 and divide it by log same base as here of 4. And that's because when I take log base whatever of this and log base whatever of this, the x comes down in front, I can divide. So as long as you remember that, we can pick a convenient base. And I think that I'd like to use 2, just like I did down here. Because I know that 2 to the third power gives me 8, so the top is just 3. The denominator is just 2, since 2 squared gives me 4. So again, I get that this log is equal to 3/2, just like we found down here. So this is just an alternate way to do this using the change of base formula. We can do the same thing with this second example. We can take log base something of 3. I'm guessing it's probably going to be 3, since I don't know anything else that would help me there, over log base 3 of 81. Now log base 3 of 3 is easy, that's just 1. Now if I think about 81, I know that's 9 times 9, and I know that each 9 is 3 times 3. So I get 3 times 3 times 3 times 3 gives me 81, so 3 to the 4th is equal to 81. So this logarithm is just 1/4. Now this has a fairly limited application. It's only problems where we can find some common base that will help us find each log that these are helpful, but still, it's an alternate way to do some of the problems we've looked at. Now for these two, I want to be able to plug these into my calculator, if for instance I was using a calculator. And I want to use the ln button on my calculator. So what I want to do is I want to change log base 17 of 26 into all ln's. And I do that, again, using the change of base formula. Tells me that ln, or log base e of 26, over ln, or log base e of 17, is the same thing as what we started with. So if I had a calculator in front of me, I could plug in ln 26 divided by ln 17, and we would get an answer for this logarithm. Now we can do the same thing for this one. We want to use ln again. So we have ln of 19 over ln of 4. Now for these two, we want to use log base 10, which we commonly just drop the 10. We just write it as log without a base. If you see a log without a base, we can always assume it's log base 10. Now, changing ln using the change of base formula, it's a little bit tricky, but all we really need to remember is that that's the exact same thing as log base e of 24. It's just a type of shorthand. So, when I use the change of base formula, I can take log base 10 of 24, which I can just write as log of 24, over log base 10 of e. So that would be my change of base formula in this case. So just remember, if you see an ln, you always assume that the base is e. And last but not least, let's take log base 29 of 3.7. we want to take log base 10, so I take log base 10 of 3.7 over log base 10 of 29. Now just one other interesting thing. Notice here I know some of the log base 4 values, especially I know for 16. Log base 4 of 16 is 2, and I know I don't get another whole number until I get to log base 4 of 64. That would be 3. So I can guess that this value, or this value now, is going to be somewhere close to 2. It's definitely between 2 and 3, but since 19 is so much closer to 16 than 64, it's likely our answer will be close to 2. So sometimes with these types of problems, you can actually get kind of a feel of what your answer will be approximately close to.